All right, guys, so we're going to review an older topic for today. So today we're talking about classifying real numbers. So you'll notice these categories over here. So basically, these categories on the left side here are going to build upon each other. So natural numbers are included in whole numbers are included in integer, and integers are included in rational. That's why they're overlapping each other. But then you'll notice this category over here, irrational, that's by itself, okay? It's a little special, so there's a reason why it's by itself. So let's look at each one individually, and we're going to see how they overlap. All right, so our first category is natural numbers. Now, natural numbers are basically your counting numbers. So when you learned to count, you started with the number one. You could count anything. You think about the little kitty shows where you were counting all sorts of different things. Okay, so it starts at one and goes from there. Now, you don't count fractional pieces of things and all that. So these are no fractions, no decimals. All right, so it's just 1, 2, 3, 4, 5, so on, so on. All right, and you'll also notice in the examples here, you've got a fraction. Fractions that equal a nice counting number are included in this category. So like 4 divided by 2 is equal to 2. So it's a counting number. So you'll also notice the one right here, the square root of 25. Since it is a perfect square, it's also included in natural numbers. So make sure when you're classifying these, you try to simplify if you can. Okay, so simplify if you can, because that may make it put into different categories. So after you learned adding and subtracting, or adding and counting, that's where you were in the natural numbers, okay? You moved on to whole numbers, okay? Now, if you look at the example for whole numbers, so it includes all of the things that are in the counting numbers. So 1, 2, 3, 4, 5, so on, fractions and decimals, they give me those numbers. And it also includes zero, okay? That's the new addition to this category. So the reason why is because once you learned how to add and count, you learn to subtract and you realize you could subtract away all that you had. Okay, so that's where these examples of zero come in. So you'll notice it right here. You also notice fractions that equal zero as well. Okay, so don't forget, if you can simplify, simplify. So after your whole numbers, you've got your integers. So integers includes all your natural numbers and your whole numbers. And then it has one big addition here, okay? So you'll notice right here, it has negative numbers. So technically, we call these the additive inverse. So it's our positive and negative whole numbers, basically. Okay, so it's the whole numbers and their opposites, okay? So here we have our negative values. Still, though, we have no fractions or decimals unless they actually divide evenly. So no fractional parts. So you'll notice this example right here, negative 10 divided by 2 is equal to negative 5. Okay, that's an integer because it's a positive or negative whole number. Okay, so then same thing with this square root right here. You see it's a negative square root of 9. So the negative in front of the square root just tells me to take the square root and then make it negative. Okay, that's where we get negative 3 from, and that is an integer. All right, now you notice that these three categories are all included in this green category right here, which is rational. Most numbers that you deal with on a day-to-day basis will fall into this category of rational. Okay, so if you notice in the examples, you've got your integers, you've got your whole numbers, you've got your counting numbers, and then you notice here at the bottom, okay, you have some fractions and decimals. So rational numbers means any number that can be written as a fraction of integers. Okay, so those positive and negative whole numbers, if I can make a fraction out of those, therefore it would be a rational number. So you'll notice the fraction right here, 1/2, that can also be written as the decimal 0.5. 0.5 is an example of a terminating decimal. Okay, so terminating decimals are in this category because they can be written as fractions and vice versa. Okay, you'll also notice the example right here, you've got 1/3. Well, 1/3, if you're not sure, is the decimal 0.3 repeating. So repeating numbers are also in this category because they can also be written as fractions. Okay, so make sure for something to be considered repeating, it has to be the exact same number over and over and over and over, or exact same set of numbers over and over and over and over. If there's a pattern, it does not mean that it is necessarily repeating. So you could have like 0.1, 0.01, 0.001. There's a pattern to it, but it's not repeating the exact same numbers in the same order over and over. Okay, so be very careful. Those are the ones that they're going to try to trick you with. Okay, this category also still has your perfect squares and cubes and your negative perfect squares and cubes as well. Okay, so just make sure the special thing added here is fractions of integers. You've got repeating decimals and terminating decimals, okay, because all of those can be written as fractions of integers. All right, our last category, again, these were all connected, okay? If it is any of these three categories, it's automatically rational. If it cannot be fit into one of these categories, it will be irrational, okay? It'll be over here by itself. All right, so irrational is kind of its own special thing. Basically, the IR here in front of irrational means not rational. So if you could not put it in the rational category, it will be in this category. Okay, so that includes non-perfect squares because you have to estimate what decimal place they would be at. It's not exact because those are non-repeating and non-terminating decimals. Okay, so again, non-perfect squares, non-perfect cubes, non-terminating decimals, non-repeating decimals are all in this. The most famous probably example of this is pi. So if you get confused, remember what's special about pi? Well, it's a number that never ends and never repeats. So it's non-terminating and non-repeating. Okay, so again, just remember, if it can fit in any of those other categories, then it would not be this. Okay, this is all or nothing. Okay, it can only be irrational, cannot be anything else. All right, so just remember when you are looking at these categories that, especially when you're trying to classify them, that you make sure that if it falls into one of these lower categories, you're including it in the ones above it as well. Okay, it is still in those categories, and it's super important that you make sure that you include it. Okay, so think about, I know when we did this in class, we did like cups. If you put it in the natural cup, it fell through to the whole integer and then landed in rational at the bottom. Okay, if I put it in irrational, it only goes to irrational. There's nothing else in that category.